In this troubleshooting exercise, you will make decisions that will take operators through the basic steps of troubleshooting a problem. To complete the exercise, you must identify the problem and its cause, and then correct the problem. The system used in this exercise was created to train operators in process control and in different types of control loops. While the process uses real equipment to create inputs to the control system, actual products are not produced. This allows operators to practice troubleshooting a variety of problems without affecting the operation of an actual process. This system transfers a liquid feed material from tanks in a tank farm to processes that use the feed material. The system consists of a suction header with valves, centrifugal pumps, inlet and outlet block valves for the pumps, and a pump discharge header with valves. The system also has a control system that monitors the levels of liquid in the tanks. The control system can also display changes in tank levels over time. As part of normal operations, the tank farm operators have been notified to transfer feed material from a storage tank to a process feed tank. The control room operator and the outside operator have coordinated their efforts to properly line up the valves in the system, and they are ready to start the transfer of feed material. After receiving permission from the control room operator, the outside operator starts the transfer pump, while the control room operator checks the appropriate indicators. The outside operator checks the operation of the pump. When the control room operator checks the indicators, he notices that the level in the storage tank is dropping and the level in the process feed tank is rising. Everything appears to be normal. The outside operator reports that the transfer pump appears to be operating properly. The control room operator records in the log that the transfer pump has been properly started. After logging the start of the pump, the control room operator again checks the indicators. This time, he finds that the level indicator for the process feed tank is not indicating any level in the tank. At this point, the operator suspects a problem. He checks other indicators for the control system and finds that the change in the level indication happened nearly instantaneously. The control room operator calls the outside operator and tells him to continue the transfer of feed material. The control room operator explains that he is troubleshooting a problem with the level in the process feed tank. The control room operator then calls his supervisor and informs him of what is happening. The control room operator calls the outside operator and has him realign the system valves to recirculate material back to the process feed tank. When the valves are realigned, the outside operator calls the control room operator and informs him. The control room operator checks the process feed tank level again and finds that it is still at 0. The control room operator has the outside operator return the system to its previous valve alignment. The control room operator calls the outside operator and tells him about the problem. The outside operator then checks the operation of the transfer pump. After checking the pump, the outside operator reports back that all local indicators for the pump appear to be at their normal values and that the feed material is being transferred properly. At this point, the problem that has been identified is that there is no level indication for the tank that the operators are pumping to. The entire system has been checked to ensure that there has been no spill of the fluid being pumped. The next troubleshooting step is to take any necessary preventive action. As a preventive action, the operators shut down the transfer pump. They know that without proper level indication in the process feed tank, there is a possibility of a spill. At this point, the control room operator decides to use the bracketing method to narrow down the cause of the problem. He starts by bracketing the transfer system into 3 parts: the transfer pump, the piping, and the process feed tank. The control room operator has the outside operator check the piping for any problems. The outside operator checks for signs of leaks or equipment damage. He also verifies that the valves in the system are in the desired positions. The outside operator finds no problems with the piping and he reports this to the control room. So, the operators rule out the piping as a possible cause of the problem. The outside operator checks to make sure that the valves for the transfer pump are in the correct positions. He also checks the transfer pump for any signs of a problem. The outside operator finds nothing wrong with the pump or the valves, so the operators eliminate these components as possible causes of the problem. The operators now focus their attention on the process feed tank and its indicators. The operators check the process feed tank by comparing the local indications with the indications in the control room. The operators start by comparing the local level indication to the value indicated in the control room. They find that the value on the local indicator is nearly the same as the value that the control room indicator had before it started to indicate no level. However, the control room indicator still indicates no level in the process feed tank. Next, the operators decide to check the positions of the valves associated with the tank and its level indicator. This process tank uses a rotometer to provide level indication. The rotometer uses compressed nitrogen to measure the level in the tank. The valve that isolates the nitrogen supply to the rotometer is found to be in the fully open position. The nitrogen supply lines are checked for any signs of damage. There are no signs of leaks in the nitrogen supply. The outside operator isolates the rotometer from its supply of nitrogen. After completing the isolation, he calls the control room and informs the operator of his actions. At this point, the rotometer is isolated, but the reason why the rotometer was not operating properly has not been determined. To continue troubleshooting, the operators decide to unisolate the rotometer. The outside operator calls the control room operator and informs him of his plans to return the system to normal operation by restarting the pump. The control room operator tells the outside operator that the pump must not be started until the rotometer is operating properly. To find the cause of the problem, the outside operator inspects the rotometer for obvious signs of damage or a problem. When he checks the valve that regulates nitrogen flow to the rotometer, the operator finds that there is too little nitrogen being supplied to the rotometer. This reduced the pressure sensed by the control system, which caused the control system to indicate no level in the tank. The control room operator has the nitrogen bank that supplies nitrogen to the rotometer checked. When this is done, he is told that the tank currently supplying nitrogen is nearly empty. To correct the problem, another nitrogen tank is placed in service. The control room operator sees that the level indication has returned to the value it had before the indication was lost. The control room indication and the local indication are now the same. After receiving permission from their supervisor, the operators restart the transfer of feed material. At this point, the process has been returned to normal service and the troubleshooting is complete.